All right, welcome to LambdaSchool JavaScript Mini Bootcamp lesson number 4. So this is our final day of the JavaScript class, and we've ramped up the difficulty pretty fast here. We started out with super basic and kind of progressed all the way through just pretty much all of the major concepts with JavaScript. And so today we're covering some of the last key parts to it. Today's going to be pretty challenging. Today's going to be pretty challenging compared to the previous days. And so anyway, don't be too worried about it. Take courage and work with your teammates in Slack, and yeah, we'll get through this. But anyway, so we're covering some quite a bit of stuff, and they're all pretty advanced concepts, but just take it one piece at a time, and no rush. Go at your own pace. And anyway, it's some really good stuff that you'll learn here. These are a lot of things that you would get asked in a JavaScript interview for like a mid-level or even a senior level JavaScript position. Like, these are the types of things that I've personally been asked quite a bit about, and had to code things like this. So yeah, so we're gonna dive into some fun stuff like that. So something I wanted to announce is that today we've had a lot of people reach out to us asking us about future plans for the mini bootcamp, because, as you know, we have our part-time and our full-time immersive programs that are coming up. And something that we decided to do today, actually, is to launch what's going to be called LambdaSchool Pro. And what we're going to be doing is we're going to continue doing this mini bootcamp model. And because we've had a lot of students reach out to us and say that they're interested in continuing to learn with us, but they just don't have either the funds or the time to be able to afford either our part-time or full-time class. And so what we're going to do is, starting next week, we're going to be doing 2 classes a week, sometimes 3, and then we're going to be just continuing these mini boot camps and covering different topics. And so next week we're going to start working on our React block. And the way LambdaSchool Pro works is it's a monthly subscription fee, so it's $14.99. Yeah, so like $15 a month, and then you'd get full access to all of the new content as well as all of the archived content. The JavaScript class and the Python class right now, those are going to be free forever. So this current group that you're in and everything, this is all just here forever. But yeah, anyway, if you're interested in learning more about LambdaSchool Pro, we just got a page up on the site. Austin will post that in the channels, and yeah, just head over there and yeah, join in, and you'll be moved to a separate Slack team. So it's totally separate from this group and all these channels and everything. So you get moved to a totally separate team, and then yeah, we're going to go through and cover new and additional concepts. So starting again with 8 lessons of React and building a blog. So anyway, there's that. We'd love to see as many of you in there as we can. All right, let's now jump into advanced JavaScript. Okay. All right. So first thing I'm going to talk about is there's some common questions that I've been asked, and so I'm going to answer a couple of these common questions that I've been asked a lot. So I want to show you a website. It's called jsbin.com. There's a bunch of websites like this, CodePen or JSFiddle. It's essentially a place where you can run your JavaScript and kind of test things out. And so I use it almost on a daily basis. I come in here, and if there's some little method with JavaScript that I want to experiment with a second, play around with it, make sure I know how it works, remember how it all functions, with how the arguments behave or whatever, and then I'll toss it in here. So for example, we're gonna talk about truthiness and falsiness in JavaScript. So the has email question from the last homework, there was a lot of questions about truthiness, falsiness, how to detect if a property exists. So I'm going to go over truthiness and falsiness. So in JavaScript, values, pretty much every value, it can be interpreted as either a true value or a false value. So every value has like a truthiness or a falsiness to it. So let me show you what that means. So I'm going to zoom in so you can see this a little too far. Okay, so let's do, all right, so let's do this. So if I do an if statement, you can actually leave the brackets off, and you can actually just put the statement right after it. So if I do this right here, anyway, this is valid syntax, and this is just pretty simple. I'm just going to throw this in like this. So if we run it, it says hi. So if true, console.log hi. So whatever is in these parentheses is going to be true, and that gets printed out here. If you're on JSBin, make sure that you're on console and not output. Output is where the HTML shows up if you're using HTML. And again, don't be stressed if you get lost on some of this stuff. Just take it slow. I'm going to try to explain each of the concepts that I cover as simply as possible, so you can go back and rewatch the video if you need to for those different sections. And then, and then the homework in the Slack team will help you work through it. So don't worry about coding along right now. Just watch. So all right. So if true, console.log hi. All right. So that ran. That works. Let's throw in a false here. Run it again. Nothing comes out, obviously. I put an exclamation mark in front, as we covered before. That reverses it. So then it prints out hi. So this now becomes true. All right. What if I put in a 0 in here? Nothing runs. So 0 is not false. So 0 has a falsiness to it. It's a falsy value. And so 0, if you put it inside of an if statement like this, 0 is considered false. 0 gets simplified to false. 1 gets simplified to true. 10, true. True. So even negative numbers are true. So everything other than 0 is true. With strings, let's say I do an empty string here. I run it, it's considered false. Put some stuff in it, now it's true. If numbers in it, it's true. An array. So an array is true. That's auto-completing, that's fine. Okay. Then object is true. I just declare a function in line like that, just empty, and run it. It's also true. Null. Null will be false. So there's truthiness and falsiness to the different values. And so if we want to detect so a common use case for this is if I have a function, then let's say I want to test if x exists, if the user passed in x. So I can go if x, or I could say like if no x. So if they didn't pass in x, then I want to return, some like error message or something like that. And so I would have to invoke it. But this is a common syntax that you'll see, just kind of a simple if statement like this at the top of the function, and it will say like if there isn't an argument, then do this. If there is no y, then return, error, something like that. So you'll commonly see this at the top of functions. That's one use case for it. The other one is, let's say we have an object that comes in called options. And so let's on here. Well, let's just do this. Let's go my function, and we're going to pass in an object to it. And then option 1 is true. Okay. So this is just invoking the function that's up here. So it's running it. We invoke it with the parentheses, and we're passing in an object. The object is just declared inline like this. So it's exactly the same as the stuff you've seen before. We're just declaring it right here. We're not assigning it to a variable name because we don't need it. We're not going to reference the object anywhere else, so we don't need a name attached to it. We're just immediately passing it into the function. So I come up in here, options comes down. Something we can do is we could say if no option, or options dot option 1, then then we'll say console.log hi, and then we could say like, let's say there's supposed to be a option 2 on there. Then we'll say no option 2. Let me move this over. All right. So now if we run this, you see no option 2 was printed out because my function had this object passed in. So options is this object. And then this right here is going to check to see options.option1. And it's going to check to see if it's truthy or falsy. And if it's truthy, then it reverses it to falsy, or it reverses it to a false value. And so then there's a false value in these parentheses. So the if statement doesn't run. It doesn't run that. So then it skips down here. So it says options.option2. And option 2 doesn't exist. So this is false. And the exclamation mark reverses it. So now there's a true value in between the parentheses. So this statement is executed. Okay, so that's truthy and falsiness. That answers some of the questions that we were seeing in the Slack channel. All right, so now let's dive into the next. Okay, so the next little JavaScript-y thing that I want to cover that gets asked about in interviews sometimes, and it's just good to know that it exists. Let's say we have this sum numbers. So this is going to sum up some numbers, and it's going to return the total. But let's say that the way we're passing it is not argument, it's arguments, or is not an array, but it's just that they can pass in an unlimited number of arguments. So for example, so if we invoke it like this, we could go 1, 2, 3, 4, 5, 6, 6, just go forever. And so, right, there we go. All right, so we can pass in whatever. We can also do something like that. So we want to be able to take in and, we want to be able to reference in a previously unknown number of arguments that are coming in. We don't know how many arguments will be passed in. And so usually your functions aren't structured this way, but anyway, there's a way that we can access all the different arguments that are coming in. And there's a thing called arguments. And it's like a pseudo array. It's not a full array. It doesn't have all the array methods on it. And so you can't do some of the same stuff that you can do with a normal array. But it has a length property on it, so you can do a for loop with it. So what we can do is we can have our total equal to 0. Let's go for var I 0, I less than arguments dot length I plus plus. All right. So now we need to add up the total. So then what we'll do is we'll go total plus equals arguments I. And then we'll go, we're just going to log the total instead of returning it. All right, so let's try this again. Boom, so we see 48 and 0. So I took and added all the numbers together, and just to make sure that this really is doing it with a number that we can easily mentally add. So 48 and 10, great. So anyway, this, yeah, so arguments, if you tried to do something like, I don't think you can do a dot push on it or pop or anyway, there's a lot of methods that aren't on this arguments thing. So it's not a full array, but it has a length property. So you can iterate over it, you can look at it and do some different things with it. So anyway, good to know this exists. You won't use it very much, but it exists as their arguments. Okay. All right, so now we're going to go over something that's called a callback function. All right, so in JavaScript, functions behave a lot like all your other values. You can pass them into other functions. You can fill up arrays with functions. You can put them on objects as methods. You can return them from functions. So today we're actually kind of playing around with some of the today we're playing around with just some of the different behaviors that that functions exhibit in JavaScript. Sorry, I'm gonna notice something real quick. Okay. All right, so yeah, okay. So we can pass in functions as arguments to other functions. Let me show you what that means. So let's have an array. We'll call it numbers. And we'll go 1, 2, 3, 4, 5. Now, let's say that we want to do, a for loop. We want to iterate over them. We want to add them all together. Just, what we just did. Summing them all. Making a total, summing them all together, or getting the sum of all the different numbers. So there's another way we can iterate over the values in the array. So we can go numbers dot for each. So for each is a method. So we're going dot for each. So just kind of like with push and pop. That we learned about before. So you have numbers dot for each. We invoke it like that. But then for each is a little different. So if you remember with numbers dot push, we can just put in a number like that, except an integer or just whatever is an argument. With for each, we pass it a function. I'm actually this right here. I'm just typing out a function in line. And then I hit enter. Boom. So it's a function that I'm actually passing in as the argument. And then behind the scenes, the for each method is going to take this function and it's going to call it once with each item in the array, starting from the beginning, and it's going to pass in that number. Okay, so let's print this out so you can see what this looks like. 1, 2, 3, 4, 5, 6. So we create the numbers array, we come down here, we push 6 onto the end, so you have 1, 2, 3, 4, 5, 6. And then now we go numbers.forEach. And so the for each method, it takes this function and it calls it once, and it passes in 1 as the argument. Calls it again, passes in 2 as the argument, calls it again with 3, calls it again with 4, calls it again with 5, and calls it again with 6. Essentially, it takes this function and it calls it once on each item in the array and passes that item in one by one. This is actually the preferred way to iterate over arrays. Once you get a little more familiar with for loops, anyway, this is the best way to do it. It's a little more clean. It's a little more readable. There's a lot less different values that you have to worry about. Anyway, I highly recommend switching to this once you're comfortable with the concept and the idea. So let's total up our numbers. Oh, one more thing is we can get the index. So the second argument that gets passed into our callback function when it gets invoked is the index. So let's go console log num and then I. So as you run it, it prints it out line after line like that. But okay, essentially what you see that num right here is 1. That's the first item. And then I is the index. So 1 is at the 0 index. And 2 is at the first index. 3 is at the second index. 4 is at the third index. Anyway, that might be it's kind of weird to look at. But all right, so that is what, anyway, that's what a callback function is. We pass a function into another function as an argument. So let's not worry about the sum part of it, the total part of it. Let's go and now see what it actually kind of looks like when we code it. So let's say that we have function, well, you know what? Sorry, the example I was going to use is actually part of the homework, so I'm going to do something different. All right, so let's make a function that is okay. Okay, we'll do search array. You know what? No, let's just do invoke callback. All right, we'll just make this real simple. All right, now this function called invoke callback. We're doing this simple just to emphasize the concept. So function invoke callback, and then now we have another function down here, and this one is going to be say hi. All right, now all this one does is say hello. So we come down here, and what we want to do is say invoke callback, we're going to pass it say hi. We're passing it that function as the argument. And so then here inside of invoke callback, we can come in here, and CB right here, these letters, this is typically what's used. You have CB as a reference to the function that's passed in. And so now in here, we can go CB, run it, and boom, we see hi printed out to the console. So say hi, the function say hi is not, we're not invoking it anywhere out here. And so when we pass it in here, we don't put parentheses on it. And so say hi isn't being invoked here. We're passing it the actual function. And then so then say hi comes into here. So CB is say hi. And then say hi right here. And then we invoke say hi. Let's do another one. Say ni hao. So this one will say ni hao. And then we'll come down here and we will invoke this invoke callback. But instead, we're going to go say ni hao. All right, so then when we invoke this one again, say ni hao is going to be CB. And then CB gets invoked right here. So hi, ni hao. So this is just showing that you can pass functions just like anything else. They get passed around just like anything else. And so you can take the function and you can stick them inside of an array. You can take the functions and stick them on objects, and we can assign variable names to them, and we can take the functions and go and pass them into other functions like this. Okay. All right, so that is the general idea with callback functions. Let's go over another one. Let's do that sum problem again, where we add up the numbers, but we're going to use a different array method. So here's numbers. I'm going to go numbers dot reduce. Okay, so reduce also takes a callback function as its argument, and reduce is kind of like for each in that it's going to be called on every single item in the array. But it does something, it has a little different behavior. And so reduce has a value it's like the running total or the aggregation, and it's a value that gets passed in each time the function gets invoked. And it makes it so you can very easily sum up all of the values, and then it gets returned. So let's do our sum gets that, and then let's log out the sum. So come in and run this again, and oh, oops, I think I wrote that wrong. Okay, great. So, all right, this is good. This happens to me every now and then in our course. So let's now go and figure this out. So Google is your best friend, and Google is how you figure out the answer to most of your programming questions. So right now I'm looking at, okay, so this, I was expecting this sum to be totaled up and returned. And I just saw what the problem was, but without me having to Google it. But what I would do is I would go in and I would Google the documentation, and I would think, okay, let's look at JS reduce. Let's go in and if I type in JS reduce, through experience I've learned that Microsoft, or Mozilla, MDN is going to pull up their reference usually first. They have this fantastic reference that goes through all the different details of the documentation for how these things work. So let's look here at their example for reduce, right? Our prototype.reduce. Okay, so var sum is, okay, so they have the array, and they go .reduce function, and then they have this and the value, return this plus the value. Okay, return. So I forgot to return. I have to return the value. So come in here, clear it. Let's run it again, and 15 gets printed out. So the way that, anyway, so Google's your best friend. Mozilla Developer Network, it can be a little tricky to read at first, but it's good. It's really good. W3 schools, their explanations sometimes are a little more simple. This place is a little more thorough. Okay, so all right, so there's a lot of, covers a lot of JavaScript right here, these 3 lines that you've learned over the last couple days. So we're declaring a variable, sum, and we're setting it equal to the result of this expression. So the computer starts reading from left to right, sees numbers. Okay, where it goes and finds the variable numbers. It says, what are you? It says, I am this array. So this array is essentially put right here. And then it calls .reduce on the array. And so reduce takes this function, passes it in. And so inside of the reduce code, the code that defines the reduce function, in there they have a loop, and they're going to loop over all these different numbers. And then they're going to call this function that we passed in, our callback function. They're going to call it once for every single item that's inside of the array. And so they're going to pass in 1, so num will be 1, then 2 will be num, then 3 will be num, then 4 will be num, then 5 will be num. And this running total, the first time the function's called, it's nothing, and then we add number to it, return that, and then in the reduce code behind the scenes, they take that number that we returned and they pass it in again the next time they call it. So this running total value keeps increasing as we change it. And so anyway, so as it gets through reduce, we get to the very end, then reduce this array, it all returns that, it returns the running total value. So this all simplifies down to whatever running total is at the end, which is the number 15. So then this all becomes var sum equals 15. And it comes down here, console, find the console object, call the log method, invoke it, and pass in the argument sum. Whereas sum, it's up here. What is sum now? Sum is 15. So 15 gets put right here. And this goes in behind the scenes and it prints it out to the console. So that's the process. That's what your code is doing. As you begin to understand the order that actions are taken, it helps you better intuitively grasp and understand how to write the code and how to achieve what you want to achieve. Okay, so I'm going to run over one more example of a callback function. So again, we're going to go over another array method that's built in. So this one's called map. So what we're going to do is we're going to go numbers.map, and then this one takes in a callback function. All right, so this one passes in the number. And what map does is it calls the function on each item in the array, starting at the beginning and going to the end. And so 1 will be the first number that's passed in. And then when 1 is passed in, what we're going to do is we're going to do some type of transformation on it, and whatever we return from this anonymous function, this callback function, is going to be placed where the 1 is in the array. So let's do this, just to kind of show you at a high level what it does. We're going to go, I'll just go, let's do that now. Log nums. So it creates a new array and returns it. Let's go clear, and let's run this. And then as you see, it's like hi. So whatever gets returned from this function is stuck into that spot in the array. So now we're going to do this is we're going to call this squares. So what we're going to do is we're going to square each number inside of the array. So we're just going to return number times number. Just times it by itself. We can do math.pow or whatever, but this is just really simple. Okay, so I'm going to change this as well. And so numbers.map is going to return an array of all the numbers squared. There, 4, 9, 16, 25. There we go. All right, so callback function, that's what a callback function is. You pass it in to another function when you invoke another method. Another method typically is when you're using a callback function. So you're using them all the time in JavaScript, all the time. And it's a little tricky at first, but eventually you'll have this down. Use them all the time with like jQuery, and that really helps you get used to it. You use them when you're like with Node and Express all the time. It's a very, very, very common pattern. Okay. All right. Okay, so the next thing is we're going to talk about constructors. So let's say in our application we need to make user objects over and over and over again, and they're going to be unique. And each user is unique to each user that's on the application, obviously. And so what we're going to do is we're going to make what's called it's kind of a class, and so they call this pseudo-classical instantiation, and it has some differences if you come from a strong like Java or C++ background. This is there are some differences, but anyway, I'm not going to go into that, but it's pseudo-classical instantiation. So essentially, we're making a template that we're going to use for all of the different user objects that we want to create. So we have function user. And we're going to say this takes in an options object. Now what we're going to do is we're going to say this dot username gets options dot username. This dot password gets options dot password, and to this dot email gets options dot email. All right, and then let's do. You know what? Let's just keep it simple for this real quick. Okay, so we have username and password, and then just to make it clear why we maybe want to use a pattern like this is, let's say that we have a function up here that let's see, salt, or we'll call this encrypt password. Let's say this takes in a password, and this isn't real encryption by any means. This is just me like kind of faking something out for like an example. So we're just going to say like, like whatever. That's what your passwords look like when they're saved in databases most of the time. Okay, so it's not really returning anything. This is just to show you why. This will make more sense in just a moment why I'm writing it this way. Okay. All right. So now we had someone's. Oh yeah, and then. Let's do, okay, and then like maybe we could do like some validations of the username or different things like, we can do some processing inside of this function on the different values that come in. Let's say we have someone sign up, and so we have, me. So let's use our user template to create an object for me as a user. So we go new user. Then we need to pass in an options object. We can pass it inline like this, and we can go username is Yiming, and then we'll go password is I love JavaScript. Okay, so now we come out here, and then let's console log Ben. And it shouldn't be capitalized. Constructors or classes are capitalized. So user right here is intentionally capitalized. Everything else is snake case and lowercase. My name right down here should be lowercase. But this constructor is uppercase. So that we use kind of a funny syntax here. We say this dot username is equal to objects, or options dot username. This dot password is equal to encrypt password, da 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 da. So this dot username makes it so it's setting. This will set a username property on the object that is created using this. When you use the new keyword, it's essentially what it's doing is behind the scenes. It's I forget the exact syntax, but it's essentially creating a new object with JavaScript, and then it's it's returning that object, whatever it's called. So so essentially what's happening is it kind of creates an object, and then you add all these different properties onto it, and then it returns it. So you don't explicitly put a return statement in here, and you don't have to create an object or anything. You just go this.username, and then that will set it on the object that's created when you invoke it. But you have to use the new keyword because the new keyword makes it so this function behaves differently. So it's kind of a little funky and a little weird. But in ES6 they have they call it syntactic sugar, but they have a class keyword that you can actually use that does all of this stuff, but in a way that looks a lot cleaner and a lot easier. And we're going to go over ES6 and in our mini class, like our LambdaSchool Pro, as well as in our upcoming courses. So, all right, Ben gets new user, username, password. Great. All right, so let's log it out, see what happens. Okay, so it's an object. And then we see password is username is Sunjiaming. Okay, great. So now let's say that we want to make another user. Let's go Austin. All right, let's go username and Austin. I think that's his Slack username. All right, and then Austin's password will be 12345. There we go. All right, so let's clear and then go run. Oh wait, let me print it out. All right, you see here that we have Austin and then we have me. And the reason that you would use a constructor is if you have, like, I mean, at a company, well, okay, so so at a company that I worked for, I was a front-end developer, but when we would do new, like, user creation or whatever, like the objects that we would have, they would have, there's like 50 different properties that they would have on it, you know, or maybe even 100. I mean, there were a lot. There was a lot of information that goes in there, like more than username and password. It would have all this stuff about like the company they're from and you know, their location and billing details and you know, address and you know, phone number and just like, you know, we'll go on and on and on. And there's all these different validation functions that we'd have to do. Every time that someone signs up with a username, we'd have to go and check and make sure that it's a unique username. You know, we can't just create a user. We have to go in and validate and make sure that the username they provided is you know, it works. With a password, we have to, you know, we have to salt it, which means you have to add some stuff to it, and then you you know, encrypt it, and then you know, store it in your database. And anyway, there's lots of different extra work that has to be done on these values that come in. And so that's generally why you would use this kind of a workflow. And so you might be thinking like options. It's like, well, the object that you're passing in has all the same values essentially as what's like being printed out. So it's like it looks like you're doubling up your work. And it's like, well, like in a real application, maybe you're passing in like where they're from, like their address. But then in here you have all these functions that would go in and validate and do all this stuff and spin up more properties on the object. And so this is actually the most efficient way to do it, is you pass in an options object that would have all the different details on it that it would need in here to build out the new user object that you would use in your application. Okay. All right, so this is, so this is how you make that constructor. This is how you make a user. I'm going to get rid of this stuff just so we can kind of simplify this down. Okay, so we have function. Okay, so let's right. We're gonna make a cat constructor. All right, so we're gonna go this dot name gets options dot name. This dot age gets options dot age. Okay. So now let's come down and make a cat. Snowball 2. Love The Simpsons. All right, the old ones. Okay, so then we're going to pass anyway, so we invoke the constructor where we're going to pass in our options objects, and then we're going to go name, and the name will be 2, and then age 5. Make that a number. Okay, so alternately, like we don't even need to be like assigning this to a variable name. I mean, honestly, what you'd be doing in your application most likely is you would be saying, you'd be doing something like you'd have like var users would be an array, and then you'd be going users.push, and you'd just be pushing the new object that is created directly into the array, and you wouldn't have an actual variable name that references it. The name that you'd be referencing it by would be actually on here. And so like that's how you'd be referencing it instead of by specifically declaring a variable name. But for the sake of this example, we're not gonna do it that way. Okay. All right, so we have a new cat that we've created. All right, so now let's say that we want to add a method to all of the cats that we create. So one way to do it is we can go this.meow and set that equal to an anonymous function in here. So let's do that. And down here we'll go snowball2.meow. Okay, so that works. And if we created, I'm just going to copy and paste this, but let's say that we create cat snowball3. And this one is 7 years old. Well, that one's newer, so we'll go 1 year. All right, so come down here, it's also going to have this method on it. So let's go meow, meow, meow. Okay. So they both work. The way, okay, I'm going to teach something for, okay. Sorry, I was about to go into one topic. I'm going to teach another one real quick. So let's say that our cat learned how to talk, and the cat can say its name now. So it's going to say, meow, my name is, and we want it to print out its name. So we try to think, okay, how can we reference the name on the cat? Because obviously we can't write snowball2.name right here because we're going to be creating maybe 1 million cats with this, different cats, and this would make it so every single one of those 1 million cats would all be looking at the snowball2 name, or maybe it would be an error if snowball2 wasn't part of their, part of the scope they're in. So the way that you reference the name is to go this.name. And we talked a little bit about that when we created objects yesterday. We'll play around with it a little bit more. So you can see that meow, my name is snowball2, meow, my name is snowball3. So we see that the 2 and the 3, like the names, were dynamically set. So this makes it so that way when this function is called, the basic rule is that you look to the left of the dot. So we have the function meow. And so this is invoked. So the meow function is invoked. We run into this. The computer wants to find out what this refers to. So it's going to look to the left of the dot for where the actual on the object instance. So it's going to say, there's the dot. What's on the left of it? Snowball3. That is the object that is this. And this one, snowball2, that is the object that is this. And so it's this context-sensitive variable that switches. So we print out, yeah, snowball2, snowball3. Okay. All right. Now let's, okay. So this is one way to add the function to all the different cat objects. But let's say that we have a giant, let's say that we have a giant function, or maybe there's 1,000 functions that that we have on there, and we don't necessarily want to copy all those every single time we create an object in memory. Maybe we have some function that's processing 1,000 users, and we don't want to have 1,000 times 1,000 of these giant functions, and it it takes up our memory and slows down our program and makes it slower. So the best practice is you actually put the function on what's called the cat prototype, the constructor prototype. So cat.prototype.meow. And then this is where we're going to stick the function. All right, so what the prototype does is it has a single function on it, and all the cat objects, they kind of inherit from this. And you can link this in between classes. I'm not going to go into that, but essentially what this is doing is it's saying that all of the cat objects, they remember the prototype that's on their constructor. And so when we make snowball2 going new cat, the snowball2 object, it remembers its constructor. And the constructor has this prototype on it that has a place where there's like a single function in memory that all of the 1,000 cat objects can all go and use. So there's one function that all of the 1,000 cat objects are using instead of each of the 1,000 cat objects having its own function. So instead of having 1,000 meow functions, there's one meow function that 1,000 cats are all using. So anyway, we just switch that out, and then this will actually work just the same. So meow. So what this will do here then is we invoke meow on snowball2. And so the computer is going to go look on the snowball2 object, and it's going to say, hey, do you have a meow function? And it's going to say no. So then it's going to go look on its prototype. It's going to look on the cat prototype, and it's going to say, hey, do you have a meow function? And it's going to say yes, and it's going to give it this function, and then that will be invoked. This is how all of the arrays in JavaScript have all these methods on them. That's because it's on the prototype. Same with the string. So I'm going to get rid of all this now. We're going to mess around with the arrays prototype. Best practice, generally, like, don't touch the prototype, but we're going to do it just so you can see how it all works. So array prototype. Array is actually a built-in JavaScript keyword. This is a constructor that's used behind the scenes to create all of the arrays. So when you're actually going var gets this, it's actually behind the scenes going new array. So it's actually using that array constructor. So we can go array.prototype.say hi. And it will go. As you see here, this escapes the single quote, so that way it doesn't close the string. Okay. So it's just going to say, I'm on the array. So now let's create an array. Notice how this is lowercase, this is uppercase. Uppercase array is a reserved keyword. You never want to overwrite that. So array, and then, okay, so now it's going on here. Let's go array.say hi. I'm on the array. So it actually added this onto every single array that's created. So prototypes. That's an introduction of the prototypes and how they work with JavaScript. All right, so we've seen new, we've seen constructors, we've seen prototype, we've gone over arguments, we've gone over callback functions, we've gone over truthy and falsy. All right, so now, all right, we got two more things that we're going to cover real quick. This next one is called closure. Okay. So functions, just like how you can pass in a callback function, functions can also return functions. So right here we have a function that we're returning. So down here we can go var inner gets outer. And then right here we're going to go all right, so when we invoke the outer function, outer is going to, it's going to run down, it's going to see return, and then it sees this anonymous function here, and it's going to return it out. So this right here simplifies down to this. And then this is a syntax that you've probably seen before, which is var inner gets, and then the synonymous function. That's essentially what this is doing. So then we can come down here and we can go inner, and we can invoke it. And think for a second, what are you going to see? Hi there. So the function gets returned. So something we can do is you can make wrappers around callback functions. And this is going to get a little complicated for a second, but this is, I technically called it an extra credit problem on the homework, but it kind of plays around with these concepts. It's going to be a little tricky. But this function that we return, this inner function, it remembers the scope from here. So if you remember with function scope, so if I create, well, let me just get rid of that for just a second. All right, so if you remember function outer, function inner. Okay, so if you remember from scope, if we have var x gets 5 right here, x, we can see x, and we can reference it inside of all of these scopes. So the inner scope can see out, but outside, they can't see in. It's like this wall. It's like a two-way mirror, one of those mirrors that you look at it from one side and you see your reflection, but then on the other side, they can see out. It's kind of like that. So like this X on the outside, he's trying to look inside of outer, but he can't. He can't see inside. It's just it's a mirror. He can't see inside of it. But inside of outer, they can see out. They can see X. But then outer, this inside of here, they can't see inside of inner. But then inner can see outer. So if we go var y gets 10, we can also reference y in here. If we go var z gets 15 in here, none of the other functions can see that 15. So this is the basics of scope. That's the basics of how scope works. It's just that functions that are on the inside can see everything on the outside. Functions on the top level can't see and access variables that are on inside functions. So with that being said, let's bring back the stuff that we had before. So we have this function outer, and then we're returning this anonymous function. So if we go var x gets 10, that's console log x. What happens is we call outer, invoke it right here, and it returns this function. Just like I walked you through before. So this is essentially like saying this. And then we come down here, and then we invoke inner. And so as we invoke inner, it comes back up, and it starts to run this function. And it goes through, and it says, OK, console. OK, so get the console object, invoke the log method, pass in x. And then it's going to say, OK, I don't have x. So it's going to look here in this function. And it's going to say, there's no x. So normally you would think that, OK, maybe it's going to throw an error. It's not going to find the x. Well, in JavaScript, it remembers where the function came from. So it remembers that this function came from here. So it's going to start looking here first for x. So it's going to go jump out, and it's going to look, and it's going to see, oh, OK, x. So x is right here. So then it takes x, and it brings it back, and it gives it to it, and it logs it out. So that is called closure. I get asked about it in interviews a lot. And it's just the idea that if you return a function from a function, the function that gets returned, it remembers the scope of the function that it was returned from. So this guy remembers the scope from where it was written. Function, when it gets returned, it remembers the scope from where it was defined, where it was written. So that's just kind of the key. And that may not seem very significant, but there's kind of some cool little tricks that we can do with it. So for example, we're going to walk through kind of a cool little problem right here. So we're going to go var limit function call count. All right, so limit function call count. So what this is going to do, this is going to take in a callback function, and then it's going to return a function. And inside of that function, it's going to call the callback function. We're going to come down here, and we're going to make our new function down here. We're going to say hi. That one's just going to log hi. Then we're going to come out here. We're going to say var new say hi is equal to limit function call count say hi. All right, we'll walk through this. So what's going to happen is right now, and we haven't added any behavior to it, but essentially this is, you know, the same as our last example that I showed. Oh, unexpected token. Syntax error. All right. Let's see. Oh, I wrote var there. Okay. All right. So limit function call count. So that takes in a callback. All right. Well, actually, let's So let's look at this as how the computer looks at it. So the computer's coming down. It sees a function here. Okay, it remembers it for later. Comes down, sees another function. Okay, remembers it for later. Comes down here. It says var new say hi. Okay, so it creates a variable. Then it's going to be equal to invoking this function, the result of invoking this function. So it's going to say limit function call count. So it's going to go grab this function, and then it knows, okay, so we're passing in say hi. So it's going to go up and it's going to find the say hi variable, which is this function, that function name. So it's going to take this function, say hi, put it right here, and pass it into this function. So CB is say hi. So then it comes down, comes to this line, it sees, oh, return. So I'm going to return whatever comes after. And it sees an anonymous function. So it goes, okay, return. So it returns this anonymous function, puts it right here in the new say hi. So new say hi is this. Come down here. Oh, it says, okay, invoke new say hi. So it invokes new say hi, it goes up and looks at new say hi, says, what is new say hi? It comes over here to see what the result was. The result was this anonymous function. So then it invokes the anonymous function. The anonymous function comes down here. It sees CB, invokes it, says, okay, what is CB? So it looks inside of this scope first, doesn't find it. So it goes and looks in its parent scope and finds it here. And CB is here. So then it logs it out, hi. So kind of a lot of like swirliness going on here, but that's essentially the workflow. But here's some cool things that we can do with it. What we can do is we can say, let's say var call count. I'm going to set this equal to 0. And then we're going to say that every time that this function is called, we're going to go call count plus plus. And then after CB, what we'll do is we'll say that we can pass in another argument. And it's the number of times we want the function to be able to be called. So we'll say 5 times. So right here, after say hi, we have to, what we'll do is we'll call this limit. And so then here, what we'll do is we'll say like 5. So we're going to say that we only want this function to be called 5 times, be able to be called. If they try to call it after that, we just return nothing. And so we have this limit. And so then now what we can do is we can go down and we can say if call count is greater than or equal to limit, then return. And then what I said to do is just going to end, and then callback will never be invoked. So then let's new say hi. Let's paste this out. All right, which is a whole bunch of times. Now let's go here to clear. Let's run it, and boom. So it actually only did it 4 times. I think the way that it's incremented, what we want to do is let's put that right here. So what happened is it incremented it too early, or I could have just changed that to be not less than or equal to, but just less than. But okay, there. So now it runs it 5 times. So we tried invoking it like 10 times, but it only ran 5 times. So anyway, this just kind of shows you this is some more advanced JavaScript. But anyway, there's some cool behavior that you can achieve by using closure and by returning functions from functions. You can create different kinds of wrappers and things that you can put on functions. And you're going to do something like that in your homework. You're going to create a caching function. And what that does is when you pass in a callback function, you're going to save any arguments that get passed into it. And then if the callback function never gets called again with the exact same arguments that it's seen before, you'll have saved that result, and so you'll directly return the result without calling the callback function. And they actually have libraries that do stuff like this, and the reason they do that is, let's say you have a function that is really expensive, it takes a long time to run, you can put something on there that kind of caches and saves results, so that way it doesn't have to run that function so much. Usually that's used on your server, between your server and your database, and so it saves results of common database queries, and so that speeds up your application quite a bit. So that's kind of extra credit. That's pretty deep. I know that just 3 days ago I was explaining what a variable was, so I know that some of you that this is going pretty deep, but just do your best to work on it, and and ask questions in Slack, and anyway, this is actually pretty advanced stuff here. Okay, so that is Clojure, and then we have one more concept that we're going to go over real quick with functions, and that is recursion. We're going to talk about recursion. Recursion is essentially another way of iterating. So we have for loops, and recursion is another way to loop. And recursion, depending on the situation, it's much more simple to iterate using recursion than it is for a for loop. If you have a really big, complicated function, there's often times where it's a lot easier to use recursion than it is to use a for loop. It takes a lot less code and a lot less brain power to think about it. But recursion can be kind of tricky initially to mentally wrap your mind around. So what we're going to do is we're going to make a function called nFibonacci, and it's going to return the nth Fibonacci number. nFibonacci. And so then that's going to take in our number, or n, well, we'll just go n. So for those of you, okay, so here's what nFibonacci looks like. So we have 1, 1, 2, 3, 5, 8, 13, 21. And so essentially what it's doing is each number is the sum of the two numbers that precede it. So 13 is 5 plus 8. 8 is 5 plus 3, 5 is 3 plus 2, 2 is 1 plus 1. Okay, so that is anyway, that's the Fibonacci sequence. And so what we're going to do is if we pass in the number 4, we want to go 1, 2, 3, 4 and return the number 3. If we put in 6, we're going to go 1, 2, 3, 4, 5, 6, take 8 and return it. If this was an 8, we would do 21. So that's what we're building right here. So now, well, anyway, so the one way that we can solve this is we can create a recursive function. And what that means is that nFibonacci is actually going to call itself inside of itself. So mind blown, right? Okay, so what that looks like is, oh, wait, I wrote this wrong. Okay, so minus 2, and then plus n minus 1. Okay, so, oh, I'm sorry, I got that wrong. Okay, so if you look right here, this matches up with that, exactly, letter for letter. It's that function. We are calling it inside of itself. And so what happens is when we call this function, it's going to come down here and it's going to say nFibonacci n minus 2. So then it's going to take, so if n is 5, it's going to come down here and it's going to say return nFibonacci of 5 minus 2 plus nFibonacci of 5 minus 1. So anyway, it passes it into itself. You have to have what's called a base case because n is going to get progressively smaller. So just like on a for loop, you have a this part right here that's I less than 10. That's the condition that stops the for loop from being an infinite loop and stops it from going on forever. You have to have a base case that you define at the top of your function. And so it's like an if statement. So we know here that n is going to be getting progressively smaller every single time it comes into the function. So what we're going to do is we're going to go if n is less than 3, return 1. And then otherwise, it's going to return this. So when 5 comes in, and Fibonacci 5, this is going to be 3. Oh, let me just run it through it, and then I'll show you. Okay, so let's do, well, all right, let's do the 20th number. Oh, okay, let me just do 3 real quick. All right, let's make sure that we got this right. Okay, all right, what do I have going on here? And Fibonacci. Let's see if n is less than 3. All right, let me just n minus 2 plus n minus 1. Okay. All right, let's see here. What did I? Let me just wrap this out and be a little more explicit. Okay. Oh, it's because I'm not console logging anything. Okay. All right, so 2. So the third number, 1, 1, 2. All right, I'm going to switch this back. Sometimes when your things break, you start thinking that, I guess, that the wrong things are wrong. Okay. All right. I jumped to the conclusion that that was causing something, but okay. So let's do the 30th number. So 832,040 is the 30th number of Fibonacci. Let's go to 300. See, there's actually a delay. This may freeze my browser, make it non-responsive, actually. Yep, froze everything. Okay, so that'll happen sometimes. So with so when you have recursive functions, what can happen is because they're calling themselves, it creates more and more copies of the function and increases the call stack. And so it actually can reach a point where yeah, it becomes non-responsive. So I'll kill the page. But all right, let me type it out again real quick. All right, so what happens then is when we call Fibonacci like 5, what's going to happen is, well, let me get this all down first. Okay, I'm gonna run that, 5, great, okay. So let me go 6, just, okay. All right, so let me write this out again. So we have 1, 1, 2, 3, 5, 8. Okay. So what happens is with n Fibonacci, 6 comes in, and then it says, is 6 less than 3? And it's not, so it comes down here. So it says return n Fibonacci of 6 minus 2, so 4. Return n Fibonacci of 4 plus n Fibonacci of 3. So with 4, what happens is 4 comes down into n, and then n comes into here. It says, is 4 less than 3? No. And so it comes down, and then it goes 4 minus 2, so n Fibonacci 2 of n Fibonacci 1. And so when this one with 1 gets called and runs in, it's going to return up a 1. So this will simplify to 1 plus 1. So those get bubbled up. Anyway, it can get kind of crazy because the different Fibonacci's functions start drilling down in different directions, and it's just gonna, because this function, when it calls itself and it feeds in the new value, it just kind of keeps cycling and cycling down until it hits a base case. And then once it hits a base case, it all starts unwinding and then bubbles back up to the top. You get your simplified value at the very top. So there's a recursive function that you're going to work on in your homework. Yeah, and so I know that this is, you guys are probably like pretty lost. This is more of just so you've seen it, so you can try working on it. It's, you know, this is very much a stretch problem. So just like, you know, this is us just kind of dumping out a lot of different information. You know, again, this one is more of like an extra credit thing. So you know, those who are more comfortable with it, you can try it. If this is overwhelming to you, you know, don't worry about it. Focus more on some of the other function stuff, some of the other object stuff. So we're just trying to cover a wide range of topics here, and you know, a broad depth of material, because then you guys can continue your self-study and return later to this on a reference. The point is not for you to be a master of all these different concepts right after this lesson. So it takes time, it takes practice, it takes writing out your own problems on your own. It takes yeah, just a lot of that continued work on your own part. So yeah, just to kind of show you that this concept exists. If this is so confusing to you, don't worry about it. Just forget it. You know, skip this problem if you need to in the homework, and you know, work on some of the other stuff. So the recursive problem that's in the homework is more simple than this one, and is a little easier to walk through. But I can post a solution to that too if you ask about it, if you're curious about it. All right. Okay, so this is the end of our JavaScript course. This is everything that we're covering. So, and again, today we did prototypes, constructors, we did callback functions, we did closure, we did recursion. So it's a lot of pretty deep stuff, and we could have honestly devoted a lesson to each one of these concepts. But again, this is supposed to, you know, we're giving you kind of an introduction to a lot of these different concepts. But we'll be going into them in much greater depth with our with our upcoming courses, as well as in our continued mini camps that we're going to keep doing with LambdaSchool Pro. Something else too is LambdaSchool Pro will be giving a free 1-year membership to all students who do our part-time and full-time courses, and so that will we'll give that to them, leading up to the course, so they can work on it and use it to get themselves ready for our part-time and full-time courses, and then they'll have access to that, for a year after graduating. So they'll have it for a year after graduating that you can use it to review and strengthen different skills and things like that. Yeah, so we still have another seat for our part-time class, and if any of you are interested, we'd love to have you guys come and apply. It's full stack JavaScript development. You'll be doing recursive stuff like this, many times in the course. Recursion will feel totally natural to you by the end of the course. Closure and stuff like this will all just be, back. You'll have this totally down, within a couple weeks into the course. Recursion is actually one of the things that we're going to talk about quite a bit in our data structures and algorithms and kind of CS fundamentals portion of the course. And so we go in a lot of that stuff very early on, and we do shoot to go pretty deep with it, but we do keep our class sizes small and provide a lot of mentorship and a lot of help to help our students be able to understand this, not just kind of dump this on you and give you homework and say good luck, but we actually we're going to work with you individually and work to make sure that you all totally understand this information. So yeah, there's a lot of really cool stuff that you'll learn. Databases, mobile development, even some machine learning and artificial intelligence, neural networks, and yeah, so cool stuff, fun stuff. We'd love to see all you guys in our future LambdaSchool Pro mini classes. Love to have you guys in our part-time and full-time immersive courses that are coming up starting April 10th. So yeah, if you have any questions about any of our courses or offerings or anything like that, send me or Austin a message on Slack or send us an email or whatever, and we'll get back to you quickly. yeah, and again, this JavaScript course and the Python course will be open to you indefinitely. You guys will be able to stay part of this Slack group indefinitely, and all that information will be here, and that community will be here. I'll be posting the homework in just a moment, so I just got to go and make it public. And yeah, I'll go and make this public right now. All right, homework is public. I will post the link. Well, thanks everyone. It's been so great to have you. We had 7,000 people sign up for this. I don't think there were 7,000 people that actually made it through to Slack for some reason, but we did have 7,000 people sign up for this, which is pretty amazing. Over 100 different countries, believe it or not. We went through and tallied them up, and there are people from every corner of the planet here. So anyway, pretty remarkable. Yeah, so feel free to reach out with any questions, and good luck with the homework.